Okay, we are back from lunch. I am recording again. Okay, so these are challenging. These right here. You just gotta, yeah, this can be very challenging right here. So we are going to use the double angle formulas to simplify. This is like what we were doing on Wednesday. So this is kind of hard to explain on this one, but what do you think this simplifies to?
Oh, it's sine of 3 theta. Maybe.
I think it looks good like that.
No, it's sine of 2 theta
It's
plus sine of theta.
No.
Can you do 2 sine theta plus, and then like in parentheses, the sine of theta? And then
That is the closest thing I have heard to where to what I think it is. Okay, Aiden's asking this, is that legal?
Yes.
2 sine cosine plus 1 sine cosine equals 3 sine cosine, right? Okay.
So it's sine 2 theta plus sine
This
theta cosine theta.
is sine of 2 theta. Now, if we want to, we can call this like half of sine 2 theta.
Why is there a cosine? I don't know. Why is there a cosine?
It's like a variable.
Oh, it's two. Yeah, sorry.
Are you good?
Yeah.
Yeah? Okay.
So it'd be 3, so it'd be 1.5 sine 2 theta.
Or 3 halves sine 2 theta. Yes. That is surprisingly as simple as you can get that one. There's just like nothing else we can go with. And that is not the same thing as 3, or that is not the same thing as sine 3 theta.
So did you just pull apart like a 2 sine theta cosine theta from that?
This is on your formula sheet.
Okay.
And also on your notes there, that 2 sine theta cosine theta is equal to sine 2 theta.
Okay.
Now, the answer to your question is, it certainly feels like I'm pulling that out of my rear end, but alas, I am not, and it is on your formula booklet. That's the one thing you gotta pay close attention to. And just to let y'all know, as the best math student I ever was, I could remember this one. I could not remember all the rest of them. I would get them screwed up all the time. So a lot of the ones we were doing on Wednesday, I knew like the back of my hand, because I got the cosine squared plus sine squared equals 1. I've got sine over cosine equals tangent. Like all of that is stored up here. But when it comes to these, I can barely get this one right. So I'm like glued to my formula booklet, and that is okay. Yeah.
I think that I'll give ID credit for this. Like, there's no reason to like.
Correct.
I don't know why like AP things like you should have to memorize it seriously.
Right. Like these are some of the things that before the AP exam we were having to like cram into our brains, and it was a lot. Okay, what about this one?
That one I got narrowed down to about 4 times, and then in parentheses cosine squared b minus 1, but that was about as far as I could get. Because first I factored out a 2 to do cosine squared 2b minus 1, and then I used double angle identity to convert it to 2 cosine squared theta minus 1.
This is You don't have to work quite that hard. But let's talk about. Oh, sorry, I didn't write that correctly.
Yeah, I was like.
Sorry, mistake.
Delete the numbers. Whoa.
So yes, I just used whiteout. Is it really that impressive? Okay, so yes, first I just factored 2 out, and if you notice, that is very similar to this right here. Okay, but in this one right here, it doesn't say theta. It says 2b. So 2 cosine squared of, sorry, I'm not, 2 cosine squared of 2b minus 1 would be, okay, what would happen if I put 2b right there for theta? It'd be 4b. So this is 2 times the cosine of 4b. It's because of this guy right here. Does that make sense?
Wait, can you like explain it one more time?
And let me just write it like this on your formula booklet. Cosine of 2b, well, shit. Oh, sorry. Cosine of 2 theta is equal to 2 cosine squared theta minus 1, right? Well, in this problem, I don't want theta. That is actually 2b. Well, then for theta here, put 2b, which would make 4b. Does that make sense?
Yeah.
Yeah, that's what I did. The original is straight from the formula booklet, but I just kind of like improvised that 2b there.
Every time I say 2 theta, I just think it says 20.
Oh, yeah. Because some people write their zeros with a slash through it. Yes, I've gotten that confused myself. Bless you.
Oh, bless you.
I'm sorry you had to sneeze into your mask. Stinks. Hate that. Okay. Expand and simplify.
What do you do with the minus?
Actually, say again?
What do you do with the minus 1?
Well, it's part of the.
Mm-hmm.
I thought the same thing.
You good?
Cosine squared 2b minus 1 is your final.
Right. No, not minus 1. That's what he was asking. It's just going to be that right there.
That's it.
Yeah, that's it. Because this whole thing is the cosine 4b. Yeah. Is that cool? Very cool. Okay. Expand and simplify. Okay, this is the one. Look at me. Look at me. This is my formulas. I'm turning them upside down.
I think it cut off.
Okay.
Plus
And,
that.
huh?
Or plus that thing at the end.
I've got to do this on a separate piece of paper.
So this is sine of 270 times the cosine of A alpha plus the cosine of 270 times the sine of alpha. Okay.
I just did it on a separate piece of paper since it gets cut off.
What is the sine of 270? Negative 1. So this would be negative 1 cosine of alpha. And what is the cosine of 270? 0 is correct. I like to keep you hanging, but yes, that is correct. And so this actually simplifies to negative cosine of alpha. Boy, my Jesus fish is not looking real swift, is it? Sorry.
It's like a Nordic
Why is
word.
alpha associated with that?
I don't know. Well, because alpha and omega, the beginning and the end.
Yeah, that
There you
makes
go.
sense.
I am the alpha.
All right, so let's recap. So far in this recording, I have said the S word, and I've talked religion.
Who are you recording this for?
Shall we, anybody who missed it, like Lily or Finley. So, yep.
Good luck.
So say hey. Hey, girls, hey. Or Ben. Ben might watch it. I know, Ben's not going to watch any video I'm going to make. That's for sure.
Imagine if he watches this and hears that.
Yeah.
I mean, it's not anything he said.
I love it.
Ooh, I love problems like this, by the way.
I don't.
I don't.
Okay, you've got to step away from the solving that we did in the last unit and go to the right triangle trig and the unit circle like we did in the unit before. Okay. Now, there are ways to do both of these.
You can use your calculator, but you want us not to.
Is there like a secret like 5, 12, 13, something like that?
It is a right triangle, okay? But really to keep everything straight here, I am going to draw a picture, okay? Like, I actually am not sure I could do this without drawing a picture. I'm just going to be quite honest with you. So what I'm going to do is I'm going to draw just a regular old right triangle in which quadrant? In quadrant 2. So, and there's my alpha. Well, apparently sine is 5 over 13. Oh, sorry, I almost wrote it in the wrong place.
And then, cosine
And my,
12/13.
by the way, Ethan's homework has some of the most lovely triangles on it that you could possibly ever imagine because he breaks out the ruler. It's so funny. Anyway, you can tell my triangle is not to scale because that does not look like 5 as compared to 13. But no matter, what would be the measure of this side? But it is going to the left, so it is negative 12. Yes. So, since we are trying to find, for part A, sine of 2 alpha is, sine of 2 alpha, let me get my, that's 2 sine alpha cosine alpha. So that's 2 times 5/13 times, what is cosine of alpha? Negative 12/13. So
that's
negative 120
5 times 12.
over 169. Is that right? Negative 120?
Yeah.
10 times 12. Yeah. Remember, 2 is not 2 over 13. It's just 2 over 1.
Yeah.
Right. So that's how we find a measure of a double angle if we know all the trig functions of the original angle.
The value of the tangent of an angle is tangent squared of that angle, the tangent of that squared. That was worded awfully.
It was. And wait, the tangent, what?
Tangent squared of theta.
Yes, is the tangent of that angle squared. Yes,
Got it.
the tangent squared. Very good. Now, and so we're going to see that right here because to do part B, tangent of 2 theta, you guys, I'm pulling it straight from the formula booklet. This is not what I am good at. I do not have this stored in my brain.
Alpha is.
How do we end up at negative 12?
Pythagorean theorem and directionally on the unit circle to the left. Mm-hmm. Yeah.
You didn't write tangent of two.
Correct. Yeah, sorry. It'll be equal to this right here. So, you guys, let's plug in tangent of theta, or alpha, or whatever letter that is. 2 times
Negative 5/12.
-5/12 over 1 minus
Negative 5/12 squared.
-5/12 is squared. That is how squaring works, like numerically there. Okay, so that's a really good. If you did not understand the whole, sine squared theta idea, that's what it is. Only it's tangent squared theta.
So that's
Oh dear.
what? Negative 25 over 144 on the bottom.
1 minus 25 over 144. What's 144 minus 25? Is that not 119? Okay. So negative 10/12. Yes, I know I could be reducing that, but what 119 over 144? Okay, so that's negative 10/12 times
120 over 144.
144 over 119. 12 goes into 144 12 times. So negative 120 over 119. Is that right? Oh, it's so close to 1.
Well, it's so close to negative 1. Yes.
And actually, I just almost had yeah, I can't do anything with that. It's just that right there. And I almost had a little come apart just then because it's like an automatic reflex of mine that when I do trig values, they cannot be over 1 or negative 1. But that's just sine and cosine. Tangent, if you recall the graph, whoop, goes way down there and way up there. So, yes, you can have values of tangent that are greater than 1. I just wanted to, kind of give you that. That's what's always going through my head, though. I was thinking I was doing sine or cosine.
I remember the frustration on the test of realizing that I couldn't do that.
Yep.
Because it's only it can only be over 1 for tangent, and also
Correct. Correct. Okay, do y'all want to try? Oh, God, there's 2 angles.
Yeah, there's 2 angles. That's the problem.
Oh, no.
Well, the first one's actually rather easy because, you can find pretty easily because it's just negative 1/3.
Okay, I'm intentionally hiding my handwriting because I have to draw some triangles. And I suggest you draw some triangles too and see if you can figure it out. And that's quadrant 3.
So that's 1
Did you write that?
24.
Oh, yeah.
1
I'm going to write something that forward.
No. Wait, no, it's 1, 2, root 5. No, it's 1, 2, root 5.
This is going to be, this is going to be this one.
Actually, just for my benefit, I would like to check that your triangles have the same measurements that mine do. It's Friday, so like I'm not feeling strongly about mine. Right?
That's so good.
And if you told me it wasn't Friday, I'd lay down right here on this floor and throw a temper tantrum. Anyway.
Oh, I know, that's stupid. Yeah.
Where did we get the square root of it?
Because this right triangle is, so that squared plus that squared equals 9. Square root is 3. Or I did 9 minus 1 and the square root of that.
That makes sense.
Yeah. And then 1, 2, square root of 5. Did I get that right? Okay. Now, there is something wrong on my diagram right here. What is it?
Not negative square root of 8.
Very good. It should be negative square root of 8 because it's to the left.
Do you?
Okay, good.
Every little test I would ever take.
Wait. Oh, yeah, that is now.
Yeah. Now, everything over here is positive, right? Because it's quadrant 1. Okay. Now, go to your formula and look at your formula and do tangent of angle A plus angle B. And I'm going to hide it here for a second.
Opposite over, No, this is opposite. No, yeah. No, that's wrong.
Okay, so let's see. Did you plug everything in correctly? Notice me, I put negative 1 over negative square root of 8. Just to, okay, so I can make that plus. I did. I put 2 over 1 just so I wouldn't screw it up. I'm not going to lie.
Oh my god, I did it wrong.
And to be honest with you, if you were actually don't worry about simplifying the heck out of this. Like, seriously, this is just 1 over square root of 8 plus 2 over 1 minus 2 over square root of 8. Is that, did I do that correctly?
Yeah.
Yeah. And you know what? Like, I'm done.
Leave it like that.
I'm done.
God, do not try to simplify.
Right. I could simplify that. I really, really could.
You could, you
But
don't want to.
it did not say put it in simplest radical form, so I am not going to waste my energy doing that.
It's my favorite.
Shouldn't that be negative 1
I
over
love this
8?
number so much.
Oh, no, because it's...
It's negative over negative. Yeah. Uh-huh.
So I'm just kind of confused about
I
that
love
process.
whatever.
So it gives you the values of each thing, and then you draw up the triangles and you guys are there. You find the value of tangent for those triangles, and then you add them all up like that.
And right, this is just from the formula booklet. Uh-huh. Yep. To what? Yes. So, let's talk about proofs. Well, before we talk about proofs, actually, I would like to kind of skip forward.
Oh, there's a back.
I would still draw a
It's just points.
right triangle here. And by the way, it says alpha is acute. So that means I would draw it in quadrant 1. Okay. I would still draw a triangle here because to find cosine of 2a, actually, yeah. So, yeah, I would still draw triangles and do them like we did these two problems. But I'd really like to move to the simplification. This is very similar to something we did on, one of the first ones. What does 2 sine of 2a cosine 2a equal?
Oh, that's equal to sine to 4x, right?
It's sine of 2 times 2a, right? So the sine of 4a. Very similar to what? That shouldn't be too much of a surprise.
It's a double thing.
So on your formula booklet, it says sine of 2 theta equals 2 sine theta cosine theta. Well, in this right here, instead of theta, it's 2a. So, therefore, I'm going to replace that with 2a.
And then the other one
Yeah.
is the same thing, but for cosine.
Cosine of what?
Cosine of tan alpha.
Yeah, because this,
Is that just
Right.
substitute that for theta and then
equals cosine of 2 theta, right? This is from my formula booklet, okay? So, if this is theta, then this is going to be the cosine of
10 alpha.
10 alpha. Uh-huh.
I said
Oh, and look at that, Jesus fish. That's a good one.
Jesus would be proud.
Jesus would be so proud.
Be careful.
I think my fish have been like,
Hey, guys. Hey, let me actually say this and on camera. Hey, come on. If I ever do offend you, please let me know. Like, don't turn it into a lawsuit. Just let me know. I will. I'll shut up. I'll stop.
I don't think you want.
I don't think you.
I want my check this way.
I'd rather get money. Than
Don't ask your parents to sue me, please. Please don't.
too late.
Okay. Ooh, more solve. Oh yes. Let's recall solving. Huh?
I've never solved anything before.
Okay. I don't mean to speak down to you, but kind of. Do you remember 2 units ago?
Oh, no.
I can barely remember 1 unit ago.
You creased your
If I had this equation, y'all looking?
Yeah, that price
And by the way, I will solve it exactly from 0 to 2 pi.
equal to like.
Okay, I'll do degrees. Sure, 30 degrees
Yeah, 30 degrees.
or
Or like
There'd be a negative
pi over 6.
30 degrees is pi over 6. What I'm saying, are y'all listen, there are 2 angles.
150 degrees.
Right, it's 150. And yes, of course, actually, I had a harder time writing this in degrees than I did radians. Like 5 pi over 6, just like it just like rolls off my hand onto my paper. But 150, I have to sit there and think about for a second. Anyway.
Sine of 2x
Now, this is the premise of what we're going to be doing, except you might be solving equations that are not just x. They might be 2x.
Okay. Well, see,
Excuse me.
So far, I've gotten into true sin x cosine x equals negative sin x.
Okay. Wait, what?
Because I expanded out the sin 2x.
Okay. And he's talking about A. There. Plus sine of x equals 0.
Yeah.
Okay, and what? Look at that real close, you guys.
Hey, wait.
Hey, guys, the premise of this, let's make sure you understand what I'm doing. Okay, so the solving from the unit before, you knew how to do this using your knowledge of the unit circle. But that's only when you have like sine, cosine, or tangent of this, just x. So that is why sometimes it is necessary to write this in terms of just x, sine, cosine, tangent of x. And so that's why I did that. Now, you may or may not have solved this in that unit.
Let's do cosine x.
What can I do?
You can
factor out the sin x.
Sine of x times,
2 cosine of x plus 1.
so now we have two problems. Yes. Either sine of x equals 0 or 2 cosine of x plus 1 equals 0. And by the way, if I got cosine of x by itself, that would be negative
Negative
1 half. Okay, so where does sine of x equal 0? 0 pi and 2 pi. Good. And where does the cosine of x equal negative 1 half?
Negative 100, or no, 120 degrees, I think. And
We probably want it in radians, right?
Right.
so that's
Yeah, no, you're right. It's 120,
so that
but
would be,
I have a hard time with that. That was 2 pi over 3.
yeah, 2 pi over 3.
And
4 pi over 3.
nice. And so if you think of that as 240,
Yeah.
yes, 120 and 240, that would be fine. But did anybody first go to 2/3 pi and 4/3 pi, like before you went to degrees?
Yes.
Okay. That, do you see your brain? Can you tell that your brain is like moving to radians rather than degrees?
I've got an image up in my mind where it's just positive and negative.
Yes.
And then outside the circle it's radians. Inside
There
the
you go.
circle it's degrees.
There you go. I like it. I like it. So this is solving using these crazy formulas, but all I did was use that one right there. It's not horrible. And by the way, can you tell that the others are going to be similar?
Yes.
I can.
It's almost like there was.
Why did the first thing? Like 2 sin x plus 1.
Okay, so y'all listen. Okay, this is a really good question that Peach is asking, so listen. When we did this was 2 units ago, right?
Yeah.
Where we were solving. And we think in terms of the unit circle, and we can only do that when it is sine of x, or cosine of x, or tangent of x. Those are the ones that we can kind of do in our head because we're imagining a. So when you have something other than just X, then you need to write it in terms of just X. And that's when I went, okay, well, I got a formula for that. And I wrote this right here. But I just left sign of X because that one's okay with me. Yeah. Actually, do y'all want to try C here? I'm probably going to skip B there. They're all very similar. Do I need to hide my paper? Are y'all trying it on your own? Actually, is this going to work out? Okay. Oh my gosh, this goes back to something I said earlier. You'll see. Whoops. Sorry.
Whoa.
The answer to this part, well, first off, are you good with what I did so far?
Yeah.
I replaced it with a single angle formula for the double angle formula. Then I factored, and then I set the factors equal to 0. And I know where the sign is 0. That's at 0, pi, and 2 pi. Okay. Where does the cosine equal negative 3/2? Huh? No. Because I'm after, where does the cosine of this single angle equal negative 3/2? What?
Nowhere.
Nowhere. It doesn't. What did I say earlier about?
Cosine and sine can't be negative.
Yes, they can.
Well, they
More than
can.
one, right?
They can't be greater than 1 or smaller than negative 1. They have to be between 1 and negative 1. They can't, that fraction cannot be improper. Maybe that's why we call fractions like that improper. Because that can't be a value for sine or cosine. There you go. There's me wrapping algebra into my world of trigonometry. Yeah. Yeah. Uh-huh. Okay. Now for the proving.
Miss Y.
Yes.
So for that, X can still equal 0, pi, and 2 pi, right?
Yes. For this problem, these are my solutions, and there are no more other than that.
Got it.
Whereas in this problem, these were all solutions. Yeah.
Okay, that's a little much.
Can you do like there we go.
I could make this a hugely inappropriate comment right now, but what you're missing on this video is 2 boys that have rulers out just to draw their unit circle like this, and they are now playing swords with them. Much like the 4.5-year-old room of preschool. Anyway, I'm just kidding. All right. And by the way, no lie, you can't see this either. Like I have this problem out. I'm ready to do it. There was something on top of my formulas, and like I moved it. Like I gotta have my formulas right here next to me because there's no way I could do that otherwise. Okay. Now, show that is also the same as prove, which means we are not going to manipulate both sides, meaning I am not going to add sine theta to both sides, or I'm not going to divide both sides by something. You've got to pick one side, work with it until it becomes the other side. I would do left.
For sure.
Yeah.
Yeah, because I mean, you don't want to like
You
re-complicate.
right. Yeah. I would rather go from complicated to simple. Actually, that's what we did in the last problem is simplify. Or not last one, but those earlier ones. We are used to simplifying. We don't want to make this any nastier than it has to be. Or than it already is. Okay, so, square root of 2 times the cosine of, this is like a plus b. Oh, good, it's plus. Oh, wait, it doesn't matter. It's backwards. Okay, so this is going to be cosine theta times the cosine of pi over 4.
Cosine pi over 4.
Hold, please. Minus, don't get me all mixed up, sine theta sine of pi over 4.
Is it not?
Now, cosine of pi over 4, like you were about to say, is?
1 over 2.
Okay,
Root 2 over 2. In this case, you actually want to keep it 1 over root 2.
I could not have put this any better than Harry just did. Cosine theta times 1 over square root of 2 minus sine of theta times 1 over square root of 2. He said, don't rationalize those like we did in another problem
Oh, 1 over root.
because square root of 2 times 1 over square root of 2 will be 1. See? That cancels out with that, so that'll just be cosine theta. And this cancels out with that, and it'll be minus sine theta, and we are done.
Whoa.
Crazy.
By the way, you do not have to do this, but if I ever show you the mark scheme for a proof, what you would see at the very bottom, what'd you say?
Smiley face?
No, you would not see a smiley face on the mark scheme. I wonder if those IB people ever smile, but anyway, you would see QED, and I'm remiss because I did not brush up on my Latin last night. QED is the acronym for the Latin phrase of essentially, this is now proved.
Quiet thumb.
Or so it is proved, or whatever. In fact, we could make that up. We could look that up. But anyway,
Sorry, I had my grammar wrong. It's quiet donna, not quiet donna.
this is proved. Is that what it says? This is proved.
Essentially,
Mm-hmm. Or proved is this. It might be backwards.
I know enough pieces of Latin to pop culture osmosis.
Yep.
And historical
Literally the exact same thing.
By the way,
Put a real spider in there.
you guys, what would be the purpose of showing this on an IB exam? This would be, yes, that's the end all be all, right? this would be part A, and by the way, this is just this was multiple problems in one, and I just chose one, but this would be part A, and part B would be, hence, find the value of square root of 2, like find square root of 2 cosine of I'll do an easy one. It would be, it would be more complicated, but I don't feel like figuring it out. But this would be the sum of what? And pi over 4. Pi and pi over 4. And since we've proved this, we can just plug it in here. So this would be cosine of pi minus sine of pi. So once you've proven it, you can just use it to plug in a value or something like that. What?
Yeah, fine tacos.
Wow, that must be the product of having this during the lunch hour. Okay. Ooh, this is a tough proof, but they tell you where to start.
Yeah.
Actually, we are doing the left side. Do what?
Yeah, because then you can do compound angles and end up with cosine 2 theta, cosine theta, not sine 2 theta, sine theta.
Actually, I could do this by using the right-hand side, I think.
You could, you don't want to.
I do
because
not.
Replace it 3 theta by 2 theta plus
2
theta, meaning that you need to start where there is a 3 theta.
Yeah. So right here, I would write this as cosine of 2 theta plus theta. Sorry about the 2 theta there, Annabelle. I did make sure you saw the. Okay, if you want to try this on your own, look down at your paper, because I am going to try to do this. Ew, okay. Let's see. Cosine. So this we think.
I'm thinking like tigers.
What are you talking about?
Tigers are like that.
Yeah, that was.
Are there any other mammals that have?
I have no idea what they're talking about. But they are mucking up my brain. So shush. I'm having to concentrate on this. Ooh.
Impossible. You just have to turn it into a variable so that it gets. Yeah.
You can.
Can you turn
Oh, wait. Sorry.
Variable, and then you can basically.
You can, but these are not the same two variables. This has a formula.
Because I'm trying to get it to turn to that. So I can
Uh-huh. but you've got to do this before you can get to that. Now from here you can turn it into whatever variable you want. Yeah.
Yeah, I wasn't exactly from this role.
Well, I think I was looking at the wrong side.
Oops. If you are not actively trying this yourself, will you at least check what I've done?
Oh,
So it's cosine third theta minus 3 sine theta cosine theta.
I'm barking up the right tree, aren't I?
I feel like the other side is
Not take the
easier.
cosine theta out of both sides.
Yeah, well, you could. However, clearly, you know what? I will go ahead and admit to you that this was not the most efficient substitution because this, I looked up here real quick. I totally checked, and out of the corner of my eye, I totally thought I was going to have sine and cosine in my answer, and I'm not. So, admittedly, I should have used 2 cosine squared theta minus 1.
Yeah, that's what I was doing, and I was like, oh, okay, I guess this way.
Do y'all want me to start over, or do you want me to keep going?
go back.
Okay. So,
Delete.
2 copy, paste, delete. So, admittedly, I was taking a wrong turn. I'm not afraid to admit that, though. So, I would do this. And,
Oh, we'll still do that.
yeah, I'll get to that in a second. So, this is going to be 2 cosine cubed theta minus cosine theta minus 2 sine squared theta cosine theta. Now, like, who doesn't belong? Okay. So instead of sine squared theta, what can I change that to?
1 minus cosine squared theta.
And the bell is about to ring. I know this. I know, right? So check this out. This would be minus 2 cosine theta plus 2 cosine squared theta and check this out.
Ellis to guidance, Kiera Ellis.
What does that make? And what does that make? Isn't that cool?
Wait, should it be a cosine cube?
Y-
Yeah.
yes. Sorry, yes. Yep. Okay, try these proofs in your book. There's some fun ones. Who kind of thinks of these proofs as like little puzzles?
I don't.
Because, like, you know, it's kind of like a jigsaw puzzle because you know what it's supposed to look like.
The thing is,
Sure.
with the jigsaw puzzles, you can usually know the boundaries of the jigsaw and how big it's going to be.
Well, these are your boundaries. The formulas are your boundaries.